Hello my Access to HE scholars. Today we are talking skeleton and muscles, and in particular joints and movement patterns. We will start off by identifying the different types of joint available in the human body, and then we'll talk about the different movement patterns that are available at those joints, and finally we'll finish off with a diagram of the common characteristics of a particular type of joint. First of all, we need to identify the three different types of joint in the human body. The first being fixed, the second being cartilaginous, and the third synovial. And they're all categorized basically on the amount of movement that are available at those joints. Now when we talk about a joint, we talk about it's a place where two or more bones meet. So we do have bones in our body that are fixed, that give no movement, such as the bones that form your cranium, or indeed your teeth. They have no movement whatsoever. Cartilaginous joints provide a slight amount of movement, and sometimes they're referred to as slightly movable joints. An example would be your vertebrae. Your spinal column can tilt left, tilt right, tilt forward, tilt back, but they have some form of movement, but they don't have a freely movable selection. And so synovial joints, for that matter, are sometimes called freely movable joints, in which case they have the greatest amount of movement. And for example, your elbow, it has a great range of movement. So those are the three types. And in the spec currently for Access to HE, you're asked to identify 6 types of freely movable joint. Well, you'll not be surprised that there are 6 types of freely movable joint, or synovial joints. So let's get into that. Here we have 6 types. This is I think taken from lumenlearning.com, and we've got a pivot joint, a hinge joint, saddle, a plane, a condyloid, and a ball and socket. And you can see that I suppose the diagrams are really sort of mechanical drawings, but you can see that from the shape of these joints, how things come together, you can see that they only will allow a certain range of movement. So what you've got to do is to be able to know an example of each, and also be able to define what they mean. So let's put this into some kind of table. So in the name we'll put the 6 different types. So we've got a gliding joint, a hinge joint, a condyloid joint, a saddle joint, a pivot joint, and ball and socket joint. So those are the 6 types of freely movable joint in the human body. So let's have a look at some examples, and we'll talk about axes and actions in a second. So let's go for the most common one that you will be familiar with, is the hinge joint. Just like the hinge on a door, the elbow joint is an example, but we don't really call it, that's not the that's not really the technical term for it. It's actually forming 2 joints between the humerus, which is in the upper arm, humerus, and the radius and the ulna. So we call those the humero-ulnar joint and the humero-radius radial joint. So So your elbow is a combination of both of those joints put together. Now when we talk about axes, I like to think about, so suppose a gear stick on a car. The axes are the different planes in which the joints can move. So in this case, a hinge really can only go forward and backwards. If you think about your elbow, it can only go up and down in terms of bicep curl. It can't really go side to side unless you move your shoulder. So your elbow joint is what's called uniaxial because it only works in one plane, i.e. it only goes in one direction, forward and backwards. Now, the actual actions that it permits, if you're a gym monkey, you will know this, it will allow flexion and extension. Flexion and extension. So doing a bicep curl, for example, lifting a weight up is flexion, and the downward phase, dropping it down, is extension. And that's the movements that are allowed at any hinge joint. So that would be the knee as well. So sort of when you're kicking out, maybe you're kicking a football, toe poking a football, when you kick it in the kicking phase, that's extension, and when you bring your leg back to try and toe poke it, that would be flexion. Another sort of common joint that we come across in the human body would be a pivot joint. Now, a pivot joint is quite unique, and if you go back a slide or back in the video, you'll see that the pivot is like something in a sort of socket like that, and the actual action that it allows, if I draw that here, is rotation. So if you imagine holding a pen by the end and then spinning it round in your fingertips, that's rotation. And so an example of a joint that would do rotation would be the radio ulnar joint. Well, wait a minute, we just said that the humero-ulnar joint does flexion and extension. Well, if you hold your elbow still and you put your palms down and then palms up, palms are down, palms up, you'll notice it's actually a different joint. So where the radius meets the ulnar is a different joint to where the humerus meets the ulnar, and that allows rotation. That allows rotation. Another example of a joint that would allow rotation would be the atlanto-axial joint, and that's basically at the top of the spine. So that's what lets you move your head from side to side. Look left, look right, look left, look right. I'm doing it with you. You can just imagine. And that's rotation, moving like an owl. And again, that's only really in one axis, so it'll only move around, and again we call that uniaxial because it only moves in one axis. Probably the most, no, let's not do that at the moment. Let's talk about the condyloid joint. The condyloid joint. Well, an example of a condyloid joint would be the knuckles, and more specifically the metacarpophalangeal. I love this name. I love that joint. What a name. The metacarpophalangeal joint. So basically, your knuckle. Now, if you look at if you hold one finger up, hold your pointy finger up. Now you can move that finger forward and backwards, That's one axis. So point to the screen and back again, point to the screen and back again. But that finger can also go from left to right, left to right, left to right, as if you're wagging a naughty finger. All right. So it can go forwards and backwards, but it can also go left and right, and that's what we're meaning by axes. So we call this biaxial, and the movements it allows is again flexion and extension. That's one of the planes of movement. So if you hold your finger to the ceiling, if you point to the screen, that would be flexion. If you pull it back as far as you can go, that would be extension. But side to side, left and right, that's also something called adduction and abduction. So if you imagine, where can I draw this? I'm running out of space. But if you imagine a person here, it's a little stick diagram of a person. If you imagine somebody with a midline running right down the middle of the body, that should be down the middle, okay, where your buttons are on a shirt, let's say. Anything that moves away from that line, I'm doing it in orange, which is not the best colour, let's do it in purple. Anything that moves away from that midline is called abduction, because you're abducting it away. So, abduction. And anything moving towards the midline of the body is adduction. Abduction, because you're sort of adding it to the body, let's say. Now the saddle, easily enough, does exactly the same. It's biaxial, it does flexion and extension, but the example here that I'm going to give you is the thumb. So if you hold your finger, if you hold your hand out, should I say, with the thumb pointing up to the sky, it will go in and out towards your finger and back again towards your finger and wrist, but it'll also go towards either side as well. So we call it biaxial, and it's flexion and extension. And we call that the carpo-metacarpal joint. Somebody at the front door, how annoying. Now I'm back. Where was I? Oh yeah, the carpo-metacarpal joint. So basically where the carpals meet the metacarpals. Where the carpals meet the metacarpals. So basically your wrist almost joins to the thumb. And the knuckles are where your metacarpals meet your phalanges, so basically your knuckles. And then the most final interesting one would be the ball and socket joint. The ball and socket joints generally would be your shoulder and your hip. They do have specific examples. So the shoulder joint would be called the glenohumeral joint. The glenohumeral joint. So obviously the humerus, and I think the gleno stands for glenoid fossa. I think that's the sort of socket, the ball part. No, it's not. What am I on about? It's the socket part, and the humerus is the ball part. So that's where the ball and socket comes in. So that's kind of the sort of cup, the fossa, the glenoid fossa. That's part of your hip joint, and then the humerus would fit into that socket. Yeah. Anyway, it's multi-axial, so it goes in all different directions. This is the most of these type of joints. The ball and socket joints are the most freely movable joints that we have, and we call that multi-axial because it can do all the combination of those above. So it can do flexion, it can do extension, it can do abduction, adduction, it can do rotation, and a combination of those things results in a new movement called circumduction, and that's a combination of all of those things. So generally if you sort of point your arm out and make a circle in the air with your finger, that's what circumduction is going on at the shoulder. So if you hold finger out, point it out, and then make a circle with your finger, that's generally circumduction. The least interesting of them all is a gliding joint, and they are basically intercarpals, intertarsals. Basically, the bones, the short cube bones of your wrist and ankle, and they basically don't do much. They don't have really many axes. In fact, they don't have an axis of movement. They just sort of glide over one another, and so we just say that's gliding. But it's the really, I think, the least impressive, the least interesting type of joint in the human body. So there's some examples for you. Let's move on. Now, what you're faced with here is the name of the movement plus the definition in the middle, and then a picture as an example. So in the top left here, we've got flexion. Flexion occurs when the angle between articulating bones decrease. All right. Now, I'm not going to insult your intelligence and read them all out, but what I will say is flexion, extension, abduction, adduction, circumduction, and rotation. They are your core 6. These are the ones that you need to learn first. Okay. Pause the video, give them a read, make sure you understand what they mean, because what we can do for extra detail, extra understanding, we can actually talk about specific types of these movements at specific joints. So for example, dorsiflexion, let me highlight these in red. Dorsiflexion at the top here occurs at the ankle when the foot is raised upwards. So you can see, let me draw on yellow, you can see that the angle of the ankle here is reducing. So that dorsiflexion is a specific type of flexion. The angle's reducing. So dorsiflexion is a specific type of flexion. Plantarflexion, good toes in ballet. You can tell I've been watching my daughters do ballet. Good toes is called plantarflexion, which is a type of extension. We've also got these two at the bottom here, supination, pronation. They're the turning your wrists downwards or upwards. They are examples of rotation, right? So when we're after extra detail, extra information for assignments or tests or whatever, you can put these bits of information in to show the extra. And it doesn't cost you very much in terms of sentencing. You don't have to explain each. For example, rotation occurs where the bone turns about its longitudinal axis. I'll put that in, longitudinal axis, which means it rotates like that pen that I talked about earlier. Where it occurs at the elbow area, we know that it's the radioulnar joint. Where it occurs at the radioulnar joint and results in palms down, that's pronation. Where it occurs, internal rotation causes pronation. External rotation at the elbow causes supination. So you can add a sentence or two on to the main definition to give that extra understanding. Elevation and depression, I wouldn't really expect on there, but I just thought I'd throw it on the slide just so that you knew. But throw it on if you've got time or that you've got the inclination to put it on. Let's have a look at some examples. So what I'm going to do is I'm going to roll the slide, and I'm not going to say anything. Pause the video, have a look at the diagram, the picture, put in your head what you think is the right answer, and then play the video and it'll excuse me, come up with the right answer. Now, I'm not going to cue you, I'm just going to basically flick them for about 3 seconds, and then 3 seconds, 3 seconds, 3 seconds, 3 seconds, or something like that. so that you can pause it, have a guess, and then go on. Pause it, have a guess, then go on. Where it's where it's tricky, I might explain why. But other than that, yeah, have a go, test yourself. Here we go. Pause it now if you like, and then I will flick forward. I think it's important for me to jump in at this point because circumduction, remember, is a combination of the two. Join a circle with the two. If you put flexion or something different, actually the movement's not being caused at the knee, it's being caused at the hip. You can't do that with your lower foot unless you rotate at the hip. So it has to be circumduction. It's the ball and socket joint of the hip that's working there, not the hinge joint of the knee. So that's where sometimes I see somebody getting it wrong. Okay, so feel free, rewind them, go through it again, just try and help to get those movement patterns in your head. The last thing that I'm going to cover is a typical synovial joint, and you'll be glad to know, pleased to know, that there isn't a great deal in this diagram. So we're going to start by drawing two bones that come together to articulate. These are the articulating bones in the joint. Now I've drawn quite a big space in there just to make it workable. What I'm going to draw on either end using a red is something we've already really, if you've seen the drawing of the long bone, label cartilage, and that's there for a shock absorber. That's there to prevent friction between the two articulating bones so they don't rub together. The bone has a membrane around it. Again, this will feature on the diagram of the long bone if you've already done that. If you haven't, you will be pleased to know that that's called the periosteum. Oh dear, periosteum. I've used a different blue as well. Rubbish. The periosteum. I've even spelled that wrong. I'm having a long day. It's been a long day. Osteum. Periosteum. That's the membrane of a bone. And funnily enough, that's where ligaments attach. So I'm going to draw some ligaments here. Oh, what's on there? Ligaments, and they sort of attach to this periosteum. They attach to this membrane of a bone. And ligaments support the joint, and they prevent unwanted movement in that joint and give it stability. They stabilize the joint. That's a good word, stabilize the joint. Now, the actual joint itself is a sealed in capsule, I suppose. Now, it has, the capsule itself has an inner lining, and that's called the synovial membrane. What that does, it filters red blood cells, which also filters red blood cells to be able to secrete fluid into the joint. So we have lots of fluid in this joint, and that fluid is called synovial fluid. Synovial fluid I've heard many times described as the WD-40 of the joints. It's a lubricating, it's a slippery, weight-bearing fluid, which again helps with suspension, helps with protection of the bones, but it also makes sure that the articulation is nice and smooth. So that's the synovial fluid, and it's the synovial membrane that creates or makes that. We also have an outer layer of this sort of capsule, and that's kind of a fibrous, that's called the fibrous OUS layer. And the fibrous layer gives the capsule, gives the synovial joint some some structure and some protection. Makes it seal the joint in. Both of those layers, so both of the layers of the synovial membrane and the fibrous layer, so the fibrous layer and the synovial membrane come together to form the capsule. And that, as they say, is that.